Well, I would imagine by now it's Wednesday for sure, and you're on the computer for sure. This video should be ChemistryA33BBlake. I already had an A and a B from last year, so I don't. Put some other numbers in. All right, so number 67, section 4 review, page 350. Says, a classmate tells you that the experimental data shows a compound's molecular formula to be 2.5 times its empirical formula. Is he correct? Well, the molecular formula has got to be a whole number, so no. Your empirical is the simplest, and those numbers can't be halves or quarters or thirds or anything like that, because you have to have whole atoms. And so if you're already taking whole numbers, when you figure out that multiplier by doing a molar mass first and dividing it in, that's always going to be 1 or 2 or 3. It's going to be a counting number. It's going to be a whole number. 68. Make sure this is running. Yeah. 68. Analysis of a compound composed of iron and oxygen yields 175 basically grams of iron and a little over 75 grams of oxygen. What is the empirical formula? Well, convert your grams to moles. Oxygen's 55.8 grams divided in is 3.13. 75.14 divided by 16 grams of oxygen comes out to be 4.7. Divide by the smallest. You need to know that. So the smallest of these two numbers is 3.13. And I think this just asks for the empirical formula. And when you do, you get about 1 and about 1.5. Now these numbers may not come out to be exactly a third or a quarter or a half. So you kind of got to read the value of it and see what you're real close to. Well, this is 1 to 1.5. Doubling that gives you 2 to 3. So it's 2 to 3 ratio. So it's hematite. It's iron 3 oxide is the iron compound, Fe2O3. And this will be a simplest formula or an empirical formula because we consider this to be ionic, not molecular, not covalent. Number 60, well, that was 68. Okay, next one. An oxide of aluminum is 0.545 grams of aluminum and 0.485 grams of oxygen. Find the empirical formula. Okay, you know how to do this. Take your grams, convert them to moles. On the periodic table, oxygen's real close to 16 grams per mole. Aluminum's real close to 27 grams per mole. So when you multiply this, well, you're going to divide by 27, and here you're going to divide by 16. You get 0.0202 and 0.0203. Well, if you divide by the smallest, 0.0202, it should be what I divided by. This should be 0.0202, not 3 down here. I'm going to leave the mistake though, because I find that interesting. See if I catch it next year. The ratio is 1 and 1.5. Well, you can't have halves of atoms, so you're going to have to double this. And so it's a 2 and a 3, Al2O3. Bauxite is the mineral name of that compound. It's aluminum oxide. Or corundum is the mineral name. Bauxite is the ore. Okay, going onward to number 70. Uh-oh, what happened? Well, apparently that's one we just talked about. All right, next, 70. Explain how percent composition data for a compound are related to the masses. Well, it looks to me like the more the mass, the higher the percent would be of the percent composition as a rule. Now, if you have more masses there, then it's also going to be reduced. But it should be, the more mass you have of something in a compound, the higher you expect its percent composition to be. How can you find the mole ratio in a chemical compound? 71. Well, divide them all by the smallest amount of moles, and that'll you end up giving you a mole ratio. 72. The molar mass of a compound is twice its empirical formula. How are they related? The molecular formula is going to be double, the subscripts are going to be double the empirical formula in that case. Wonder if I somehow inadvertently deleted a page out of there. It's possible. 73. Hematite, Fe2O3. I told you it was Fe2O3. And magnetite, Fe3O4, are two ores used as sources of iron. Which one provides the greater percentage of iron per kilogram? So you don't have to do the complete percent composition here, but you have to figure out the molar mass of each other and find iron's composition. So if you, for both of them, find their molar mass, and maybe I should have done this in blue because I always do molar masses in blue, and here I did not. I have 2 irons times 55.8 is 111.6. 3 oxygen times 16 is 48. Hematite comes out to 159.7 grams per mole. Magnetite is 3 iron times 55.8 is 167.4. 4 oxygen times 16 is 64 grams per mole, for a total of 231.4 grams per mole. Now, you might be able to look at these and figure out, but the one has more iron, magnetite has more iron and more oxygen, so that's a little dangerous to do that. By calculating it, we can be a little more sure. So all we have to do is calculate 2 irons, divide this by this basically, and this by this, and we have the percent composition just for those 2 iron amounts. Okay, so if I take 111.6 divided by 159.7, we don't need to worry about the oxygen. That's 70%. Here, 167.4 divided by 2.31.4 is 72%. So this one's a little richer. And we could use that. So if you had a choice, all other factors being equal, you'd mine this stuff because the percentage is a little higher, be a little richer. Okay, so let's talk about hydrates. I know I've got a video on that on the next one. A hydrate is a compound. It's probably ionic. Our examples are going to be ionic. It has water molecules bound to it. And I've shown you hydrates. In freshman year, we had nickel ammonium sulfate hydrate. We dried the water out. We did a lab with copper 2 sulfate hydrate, dried it out. We're going to do a lab here where we heat up a hydrate and drive the water off. That's be the next lab we do. That's going to be time consuming. Okay, so you can determine the percent composition. Here, you're just looking at the mole ratio of the compound to water. So let's see if I have an example right here. Okay, so what you do, I don't know if you remember that lab in last year where we had a test tube and I had blue copper 2 sulfate hydrate in there. And it heated up and it drove the water off and it turned white, and then we dripped water back down and it turned back blue. You can take your compound that's a hydrate, and in the bottom of this desiccator here, you can, I can't get this off, it's so greasy. But there's a metal mesh, and underneath of that, in the plastic, you could put calcium chloride, which is also a hydrate. CaCl2 dot 2H2O, calcium chloride. So we talked about hydrates last year. CaCl2 dot 2H2O, calcium chloride. But what we do, it's down here, by the way. There's a cobalt 2 chloride hydrate in here that's been dehydrated, because this calcium chloride that's down here was heated up. And drove the water away. And now it's calcium 2 chloride with no water on it. And you can't really tell by looking at it whether or not it's hydrated. And then we're trying to take water off this cobalt 2 chloride hydrate. Because when it's wet, instead of being blue like that, it's pink with its hydrate form. And this is with water in there. So what that calcium chloride, the white pellets in the bottom are doing, it's a desiccant. It is taking water up out of that atmosphere, getting it extremely dry. And then the cobalt 2 chloride, which was moist and hydrated and pink, is giving up its water and becoming dehydrated, and it turns a different color. So the other one is cobalt 2 chloride. I think it's cobalt 2 chloride. Dot. I forget how many waters are on that. I want to say 7, but I'm not sure. Can't remember if it's 7 or 2. Okay, so we want to know the percent composition of a compound. Okay, so to name the hydrates, refer to tables 1, page 351. It's right here. Mono, di, tri, tetra, penta, hexa, hepta, octa. Okay, so that's what's going on with those hydrates. And the next problem, you've got magnesium. It's cobalt 2 chloride, because there's a question about it. We'll do that on the next video. And so the next video, what we're going to do is go to magnesium sulfate, Epsom salt. So I've got some, maybe I'll get this out here. You've used Epsom salts. It was one of the white powders in the 9 white powders lab, and it's a hydrate. And you can heat magnesium sulfate up and drive the water off of it. Okay, so that's where we'll end this video, and then the rest of them probably Thursday.